Yes, we are now on part B Roman 2 that wants us to get the median. So we are redefining our capital F of x. So our capital F of x was a 0. That is when x is less or equal to 0. It is x squared over 16. This is when x is between 0 and 4. It is a 1. This is when x is greater or equal to a 4. We are on the median. You begin by, this is Roman 2. You begin by redefining the capital F of x. Now, after redefining it, of course, you must get the median interval using that capital F of x. So we are inspecting each interval at a time. And that interval whose capital F of x is at least a half would be the median interval. So I am beginning with this first one. I'm testing for the median interval. Now my capital F, this is for the first interval, which is x is less or equal to 0. My capital F for x is a 0. This is when x is less or equal to 0. But remember, the capital F of x of the median interval must be at least a half. So since the capital F of x for the first interval is a 0, it means x is less or equal to 0 is not the median interval. So since capital F of x, which is a 0, is less than a half, this is for the interval. Okay, then x is less or equal to 0 is not the median interval. After inspecting it in the first one, then we go for the second one. Our second interval is this. So I am testing for whether 0 is less or equal to x less or equal to 4 is the median interval. So our capital F of x in this interval is x squared. So my capital F of x is going to be x squared over 16. This is when x lies between 0 and 4. So if I want to get the capital F of x of this interval, I substitute in this and this in this function. So my capital F of x for this particular interval is going to be capital F of 4 minus capital F of 0. Put in a 4, we shall have a 4 squared over 16 minus a 0 squared over 16, and your capital F of x is going to be a 1. Now, once you realize that it is a 1 for any given interval, once you realize that it is beyond a half for any particular interval, you go interval by interval. Once the condition is satisfied, you don't progress to the next one. Now, we started with this first one. Capital F of x was a 0, which was less than a half, implying this is not x is less or equal to 0, is not the median interval. That is the reason why we went for this second one. Now, since when you substitute these two values in this, you get a value which is greater than a half, then you don't go to test the last one because the condition has already been satisfied by this. So we can now conclude here and say that since capital F of x, which is 1, is greater than a half, then 0 is less or equal to x less or equal to 4 is the median interval. Now, after getting it as the median interval, the next step is since this is the median interval, the next step now implies that the median is somewhere in the middle of 0 and a 4. So it means if we let m to be the median, then that median value lies between, if this is 0, this is the median interval from 0 to 4, then the median lies somewhere there, in between 0 and a 4. So my capital F of x for that interval where the median lies is x squared over 16. This is when 0 is less or equal to 4. But the capital F of m of the median interval, remember our median is already between 0 and 4. Our capital F of m in the median interval must be a half. So we are going to get this m and substitute it in this function where the median lies. So you remove m and you remove x and you replace x with m. We shall have m squared over 16 is equal to a half. So our m squared is going to be 8 and the m will be plus or minus 2 over 2. And because our median must be between 0 and 4, we have values of m. There is negative 2 root 2. This is out of range since the median lies between 0 and 4. Then also test the second one. The second value of m is a 2 root 2. This is in range, and because it is in the range, then you conclude and say that the median is equal to 2 root 2, and that is how we get the median of a simple PDF of a continuous random variable, like that one that I have dealt with. So in our next video, we shall look at a case when the PDF is compound, and then we analyze how do we then get the CDF capital F of x, and it is from that basis that we shall also see how do you move from a CDF back to the PDF, as we noted earlier that whenever we are moving from a CDF back to the PDF, we do the differentiation.